So in classical mechanics, the state of a system is defined by the position and the momentum. Okay, but we cannot measure the position and momentum in quantum mechanics simultaneously. Then we are violating the Heisenberg uncertainty principle. So then what can we do in case of quantum mechanics? So what can we do in case of quantum mechanics? How the state of this quantum mechanics system can be specified? It is specified by the wave function. It is specified by the wave function. This is the wave function. We denote psi of x as the wave function. Of x means it is one-dimensional. If it is three-dimensional, we should write r. So the configuration or the state of a quantum object is determined by the wave function. Actually, what does this sentence means? This means that the wave function gives the space-time behavior of a quantum system. How the quantum system is behaving with respect to the space and with respect to the time. We are not teaching you relativity, but time in relativity is taken to be the fourth dimension. And there can be a conversion, interconversion of space and time. Okay, so the wave function, this statement says that the wave function define or explain or specify the space-time behavior of a quantum system. This psi, we cannot, by any physical experiment, we cannot measure psi directly. Means there is no such experiment where we can directly measure psi. But if we have a knowledge of psi, what does this mean? Means the nature of psi, whether it is logarithmic, whether it is exponential. If it is exponential, what is the type of, what is the form of that one? If we have a knowledge of that psi, then with the help of that knowledge, we can find out or evaluate the parameters for, say, the momentum, say, the position, the energy, whether mechanical or, potential or kinetic. All these parameters can be determined if you have a knowledge of psi. But we cannot measure psi directly. There is no physical experiment where we can measure psi. And what does this psi do? It is giving the space-time behavior of a particle. So mathematically, how we can define psi? It is physically, it is giving the space-time behavior of a particle. Mathematically, it gives the measure of finding the probability of a particle within a specified region. A region is specified, say your classroom. A region is specified, say your classroom of F4, okay? And we want to find the probability of finding out Bhumi. So we should know psi. Okay, clear? And this gives the probabilistic approach. So psi gives the probability for finding the particle at a given location in space and is referred to as probability density. And how we find out? T, the probability density, say, of R and T, means three-dimensional we are writing, is equals to psi into psi star. Psi star is complex conjugate of psi. If Z equals to X plus IY, then Z star complex conjugate will be X minus IY. So psi is actually imaginary in nature. Whereas if you think about the wave function of classical mechanics, that is not imaginary. Okay, and since probability is real, we find multiplying psi star with psi, we find that this is a real value. This is modulus of psi square. So this P d tau means if we have to find out the probability, that means we have to integrate this equation. We have to integrate this expression, rather, we have to integrate this expression and we have to find out. We will do some sums, nothing to worry. Okay. So this is what we call psi. Any question? Bujha gelo? Do you want to ask any question? You can.
স্যার তলায় ওই ডি টাউটা ওটা কি লাগাই বুঝতে পারলাম না।
D tau is the elemental volume. D tau is the elemental volume means if we are talking about
dx dy আর dz ওইটা
if we are talking about a small elemental volume of dx dy and dz, dx dy dz, that can be denoted as dv or d tau, and p d tau is the probability density, say from a to b, that is equals to from a to b psi star d tau. If it is in one dimensional, then d tau will be replaced by dx. As simple as that. If it is along x-axis. If it is along y-axis dy, if it is along z-axis dz. So the expression of psi will be given to you. You have to find out psi star. You have to find out psi star. Then if you integrate within the specified region which has been given to you, and if you integrate this one, you will get the value of the probability of finding the particle. This way how we do the sums. Clear? Okay. Okay. So this is what we call psi. Okay. So psi is the wave function. Again, I am telling you, psi is the wave function which is giving the space-time behavior of the particle. Space-time behavior of the particle means actually mathematically we are finding out the probability for finding the particle. We cannot measure psi directly by any physical experiment, but obviously we can